Hello everyone, my name is Mathieu Liénard and welcome back to my AWS demo channel. I know it has been a while, but I was busy and I am coming back with a cool one. In September, I attended the Swiss Python Summit where Radomir Dopieralski, sorry if I am pronouncing the name incorrectly, was presenting game development with CircuitPython on his Pew Pew device microcontrollers. I immediately came up with one of my usual stupid ideas. What if I could connect one of these devices to AWS IoT, and when I would lose the game, it would create a chaos engineering experiment on my infrastructure in AWS using the AWS Fault Injection service. Unfortunately, the Pew Pew devices do not have Wi-Fi. So I purchased this Adafruit PyPortal microcontroller, which also runs CircuitPython. It has a touchscreen and a Wi-Fi chip. And with this device, this is what I am going to demo my AWS Monster Chaos game. I will make another video explaining all the stacks I developed with the AWS CDK and releasing all the code on GitHub hopefully soon. In this demo, I will show you the game I play on the Adafruit PyPortal and how it triggers the chaos engineering experiment in my AWS infrastructure. For this demo, I needed an application infrastructure on which I could perform chaos engineering. As mentioned, I will go into the details in the next video, but very quickly, this is the architecture. It is a 4-tier application with a load balancer, an Nginx reverse proxy, a Node.js server, and a DynamoDB NoSQL database backend in 3 availability zones. This architecture was designed to provide many possibilities to release monsters to generate chaos. And this is what the application looks like. A very simple web page showing how many times you won or lost by surviving the monster chaos. Now, there are 2 games in this monster chaos game. First, there is the game that you want to lose. This is the game you play on the Adafruit PyPortal. It is a modified Minesweeper game made by Adafruit, and you want to lose this game to trigger the fault injection experiment in AWS. Then there is the game that you want to win. You score points, and they are shown on the web application webpage, when your application survived the chaos generated by the monster released in your application from the PyPortal device. So let's go play some games and release some monsters in AWS. First, here we can see the application running. There are 2 Nginx service containers and 3 application service containers running. And we can see here on the left side the application itself, and currently we haven't played any game, so the score is 0 either way. Let's switch to the PyPortal game and start playing. Now we can play the game, and again the objective here is to lose this game, this monster sweeper game, in order to release monsters in our application infrastructure in AWS to generate chaos. So let's lose this game. Well, that was easy. Now if we switch back to the AWS console, we should see here a new fault injection experiment running. If we look at the template, this one will stop all the web application Fargate containers. Obviously, this will generate, as we can see immediately here on the left, a problem in the application as we killed all the web application service tasks. So the application is not working anymore. And we will have to wait for the experiment to finish. Currently, it is still running. We should see the service tasks being reprovisioned as the old ones were terminated. If we check here, even if the application containers are back up and running, the application is still not working. This is done on purpose. I on purpose misconfigured the Nginx reverse proxy to not use the resolver. So it is caching the IP addresses of the application service tasks. But as they were terminated and new ones provisioned with new IPs, the Nginx reverse proxy is still trying to connect to the IPs of the terminated ones, which obviously is not going to work. I did that on purpose as part of the demo to simulate the case when the application is not surviving the chaos generated by the little monsters. So if we go to CloudWatch, we can see an alarm being raised. Because an alarm is being raised, the fault injection experiment is going to be stopped. I will have to manually terminate the Nginx service tasks for new ones to start and use the new web app service tasks IPs. I will pause the video and come back when the Nginx service tasks are back up and the application is running. Here we are, all the service tasks are back up, and we see on the left the application is also back up and we lost one game. Again, this was made on purpose. I misconfigured the Nginx reverse proxy without a resolver on purpose to simulate a case when the little monsters are generating chaos in the application and the application is not able to survive the chaos. This makes us lose this chaos game. Let's go back and try to play another game. I am back on my PyPortal trying to play a game that I will try to lose again. Hopefully that will release a different type of chaos monster, triggering a different fault injection experiment. Let's go back to the AWS console. We see here a new experiment running. It is a different one. Let's look at the template. This time it will stop all the Nginx service tasks. Of course, here this will also have an impact on the application, which will stop working for a while. But if we go uncheck in ECS, the Nginx service tasks are already restored and the application is back. So there was a service interruption, but the application recovered fast enough and it will not raise an alarm. Because no alarm will be raised, the experiment will continue to the end of the timer and complete. As a result, we will win this game. Let me pause the video and come back when the experiment is complete. Here we are. The fault injection experiment has completed. And we can see here our score being updated, and now we have a tie. And sure, it had a temporary impact on the application as it stopped all the Nginx service tasks, but not to the point that it raised an alarm and stopped the experiment. Let's try a third time to break this tie and see if overall we can win or lose this game. Let's go back to the PyPortal. Let's see what type of chaos monster will be released in my application this time. That was an easy game to lose again. Let's go back to the AWS console. If we refresh the experiments, this time it stopped just one service task. And we can see here in the ECS console where we have just 5 tasks and just 2 web application tasks. This time this should not have any impact on the application. we should not see any downtime like we did in the previous two experiments. In this case, the fault injection experiment should complete and we should win this chaos game. We can see on the left that there is no downtime in the application, and a third web application service task is back up. Let me pause the video and come back when the experiment completes. So that's it, the experiment completed, no alarm was raised, and we can see our score being updated. We won this game too. So that's it. This was my demo of my AWS Monster Chaos game using an Adafruit PyPortal and the AWS Fault Injection service. I will go in the next video in the details of how everything works together between the Adafruit PyPortal, the AWS IoT stack, the fault injection stack, and the application stack. So stay tuned for the next video, and I will be releasing all the code together with the next video. Thank you for watching and see you next time. Let me see if I can actually win this game. Yes, I was able to at least win this game also.